Macam ni pula kan, ini kali terakhir lah. Ini adalah topik terakhir yang awak akan tekan calculator. Okay, so the rest of the topic kita akan belajar organic chemistry ya, esok. Okay, so let's start lah. Okay, Faraday law. So what is Faraday law? So Faraday said that amount of substance produced at each of the electrode is directly proportional to the quantity of charge flowing through the cell. So maksud dia apa kat sini? So maksudnya kalau awak bagi current sebanyak itu, so amount of product pun banyak itulah. So kalau you supply sikit saja current, okay, so maksudnya produk awak nanti sikit lah. So itu maksud, itu apa yang Faraday cuba sampaikan. Okay, amount of substance produced at each of the electrode is directly proportional to the quantity of the charge. Okay, dia ada apa formula? So the formula is Q equals to IT. So I is the current. Okay, unit untuk current adalah ampere. Okay, T pula time. Time untuk kes ini adalah dalam second. So Q adalah quantity of charge. So the overall unit nanti untuk Q, the unit is coulomb. Okay, ataupun kita akan guna simbol sahajalah, which is C. Okay, so how do we measure quantity of the charge? Okay, let's say kita ada the first half cell, which is silver electrode. Okay, so from the equation, we have 1 mole of electron here. Okay, we have 1 mole of electron. Kenapa tak jadi bulat? Okay, so 1 mole of electron corresponds to 1 Faraday. Okay, so 1 mole of electron corresponds to 1 Faraday. So let's have another half cell. Okay, this time around we have aluminium. So aluminium, this is the equation lah. So from the equation, kita ada 3 mole of electron. So 3 mole of electron corresponds to 3 Faraday. Okay, 3 Faraday. Okay, next half cell, kita ada zinc half cell. So from the balance equation, kita ada 2 mole of electron. So 2 mole of electron corresponds to 2 Faraday. Okay, so daripada situ kita boleh dapatkan quantity of charge. Okay, now, apa kaitan Faraday dengan coulomb tadi? Okay, kita lupa pula kat sini ya. So 1 Faraday corresponds to 96,500 coulomb. So 1 Faraday bersamaan dengan 96,500 coulomb. So kita akan interchange here nantilah. Okay guys, so let's start. I will show you the first one. Okay, practice question 1. Okay, so an aqueous solution of copper sulfate is electrolyzed using a current of 0.15 ampere for 5 hours. Calculate mass of the copper deposited at the cathode. So means that we are going to focus on half equation at cathode only. Okay, so next, okay, kita ada dia bagi current, dia bagi time. Okay, so from the given current and time, we can find out the Q. Okay, so Madam dah buat dekat sini untuk awak. So this one. Okay, cuma time dia bagi dalam hour. We have to convert into second. So when you multiply this thing, so you will have 2,700 coulomb. Okay, 2,700 coulomb. So basically this is the charge provided. Okay, this is the charge provided. Okay, so kita tahulah at cathode. Okay, dia dah bagi tahu siap-siap kat sini. Copper deposited at cathode. Maksudnya when we do the electrolysis, okay, so ingat balik electrolysis, ini adalah aqueous copper sulfate. So we have 3 species. Okay, so since the question already mentioned copper deposited at cathode, so kita tahulah yang spesies yang terpilih adalah copper. Okay, so at cathode, so first we write down the half cell equation for copper. So make sure this one correct. Okay, so at cathode, copper 2 plus accept electron to form copper electron. Okay guys, so from the balance equation here, so this is the important part. So we have 2 mole of electron. So kita tahu 2 mole of electron corresponds to 2 Faraday. Okay, 2 Faraday ni, Faraday, kita convert pula jadi dalam coulomb. So kita tahu 1 Faraday corresponds to 965,000 coulomb. So kalau 2 Faraday, so times by 2 lah. Okay, that's why I times 2 over here. Okay, so last one we get 193,193,000 coulomb. Okay, so what is the difference between these two values? So take note sikit dekat situ, buat nota sikit. So this one is the theoretical value. Kenapa kita panggil dia theoretical value? Sebab kita dapatkan amount of charge here based on the equation. So this one is the actual charge that you supply. Okay, so that's the difference between the value lah. Okay, so sekarang ni kita fokus dekat copper. Because we want to find out how much of copper deposited. So from the equation, so maksudnya in order to produce 1 mole of copper, you need 193,000 coulomb. Tapi awak bukan nak 1 mole. Awak nak So this is the theoretical part lah. But you don't have this much charge. You only have this one. Okay. So kita darab silang. So this one divided by this one and times 1. So this is what you should have. 0.014 mole of copper. Okay, so if you ask me, Madam, boleh tak saya nak tulis ni dulu, then ni kat tepi? Boleh, tak ada masalah. Okay, so next to find out mass of copper, so kita dah dapat mole tadi kan? So darab dengan molar mass dia. So you should have 0.889 gram. Okay, so that is the mass of copper deposited at cathode. So ingat balik, kalau electrolysis dekat anode, ya anode kan, so anode mass decrease. Kalau at cathode, mass increase. Okay, so that's the first one. That's the first one. Okay, next example. Okay, let's have this together. An aqueous solution of copper nitrate was electrolyzed using a current of 1.5 ampere for 60 minutes at 25 degrees C and 180 M. Calculate mass of copper metal deposited. Okay, macam tadi. And this time around, dia nak suruh cari volume of gas involved at anode. Okay, so before you start, make sure you label supaya kita tahu apa yang kita ada. Okay, copper nitrate Cu NO3 2. Okay, that's the formula of the copper nitrate. So kita ada I, kita ada T, dan kita ada suhu at STP. Okay, that is the information at STP. So first calculate mass of copper deposited. So you ada I, you ada T. So macam tadi, so use the formula. Okay, use the formula to find out the charge that you have, okay, that you supply. So 1.5 times 60 times 60. Remember, the time must be in second. So you should have 5,400 coulomb. Sorry, nampak macam G pula. Okay, cool. So that's the actual charge that you have. Okay, next at cathode. So kita tahu lah equation at cathode is like this. Okay, from the equation, 2 mole of electron corresponds to 2 Faraday. So Faraday ni kita kembangkan jadi coulomb lah sebab kita nak compare dengan yang di atas nanti. Okay, so to produce 1 mole of copper, you need 193,000 coulomb, but you only have this much. So the actual number of mole that you have is this much. Okay, 0.028 mole copper. So once you dapat mole, so you times with the molar mass and you will get the mass of copper deposited at cathode. So you should have 1.778. So sambil-sambil awak dengar tu, please press your calculator, takut madam pun ada tersilap kira nanti. Okay, because I don't have the scheme for this one, so please double check my answer. Okay guys, so next dia kata gas evolve at anode. Okay guys, ini yang selalu student buat mistake kan. Gas apa? Kita tak tahu gas apa. So I advise you guys for this kind of question, you you sketch the electrolytic cell. Okay, sketch the electrolytic cell. So the electrode, 2 electrode. Okay, the electrolyte. Okay. Okay, anode, cathode. So kita tak tahu copper nitrate. So this is the solution of copper 2 plus, NO3 minus, and water. So basically in this solution you have these 3 species. Okay, let's say lah kita guna platinum for both of the electrode. Okay, now ingat balik at anode is the positive terminal, so anion will attracted to anode lah. So NO3 minus and water. So this one At cathode Cu2 plus and water. So dah tak perlu tengok dekat cathode lah, kita fokus dekat anode sekarang. Okay, so we have NO3 minus and water. But we learned yesterday that oxo anion, this is oxo anion, dia tidak akan oxidize. So means that dia tidak akan terpilih lah to be discharged at anode. So the chosen one is water. So you have to know water at anode, dia produce oxygen gas. Okay. So you have to use this one. This formula pula. This equation. Okay. Equation of water produce oxygen gas. Okay, this one you can do on your own or you can refer to this table. Sorry. This one. Tapi you kena terbalikkan lah sebab the equation is standard reduction kan. So kita ubah dia punya position. Sebab sekarang kita nak tulis equation for anode. Okay, so next proceed. From the balance equation, we have 4 mole of electron. 4 mole of electron corresponds to 4 Faraday. So 4 darab 96500 tadi. So you should get 386,000 coulomb. 386,000 coulomb. Okay. So take note dekat situ. Okay, so itu secara teorinya lah. So basically from the equation, 1 mole of oxygen, to produce 1 mole of oxygen gas, you need 386,000 coulomb. Okay, so you need this much. However, you only has this much, 5,400 saja. So do the darab silang things. So bahagi dulu 5,000 ni bahagi dengan 386. So darab 1. Then you will have 0.014 mole oxygen. Kalau tak silap madam, dia punya mole adalah 0.01399 something. So I bundarkan. So kita ambil 4 significant figure. Okay, so you should have 0.014 mole. Okay, so once dah dapat mole, kita akan cari volume sebab soalan nak suruh cari volume. So at STP, how do we know at STP? Because the condition given is at STP. Okay, so ingat balik kan kita ada belajar volume sama dengan volume pula. Mole sama dengan volume over molar volume kan. So kita nak cari volume. So mole darab molar volume lah. Okay, so molar volume in this case is 22.4 mole per liter. Liter per mole. So tekan calculator. You should have 0.3136 liter. Okay, sebab kenapa liter? Sebab unit dekat sini adalah liter per mole. Dia minta spesifik tak apa? Okay guys, so that's why it is really important for you guys to be able to write down the equation at anode and cathode. Okay, because it strongly related to the Faraday. So Faraday ni senang cerita dia cakap macam ni. Kalau you ada charge sikit, so makanya mass yang terhasil nanti sikit lah. Okay, kalau charge awak banyak, so banyaklah produk awak nanti. So that's the second example. Okay, I will show you the last one and then you will do on your own lah. Okay, so this one, the electrolysis of a sodium sulfate solution produces 0.84 liter of oxygen gas at 1 atm and 25 degrees Celsius. Calculate number of Faraday required for the process. Okay, so sodium sulfate, sodium Na, SO4. Okay, so that's the compound lah. Okay, latih diri awak untuk tulis compound. Contohkan sodium ion dia Na+, sulfate ion SO4 to minus. Then you darab silang, you dapatlah Na2SO4. So basically we have volume of the oxygen, we have condition given at STP. Okay, kita bukan nak kira pressure ke temperature, tak ada ya. And kita nak cari number of Faraday. Okay, kita nak cari berapa banyak Faraday yang kita perlukan. Okay, so since you are given the volume, okay, volume of oxygen, so kita cari dulu more of the oxygen. Okay, so tapi kita bukan guna mass over molar mass, kita guna volume macam tadilah, volume over molar volume. Okay, so the volume already in liter, so you should get 0.0375 mol. Okay, 0.0375 mol. Okay, at anode, sodium sulfate. Tapi kat sini dia dah cakap produces 0.84 liter of oxygen. So maksudnya oxygen is produced at anode lah. Okay, memang oxygen dia takkan pergi dekat cathode. Oxygen only produced at anode. So means that at anode, water discharge into oxygen ataupun water produce oxygen gas. So from the equation, 4 mole of electron corresponds to 4 Faraday. So nak, okay, 4 electron, so 4 Faraday lah. Nak hasilkan, maksudnya nak hasilkan 1 mole of oxygen, kita perlukan 4 Faraday. Tapi kita bukan ada 1 mole, kita ada hanyalah 0.0375 mol. Yang ini darab silang, this one dah bahagi darab 4. So you should have 0.15 Faraday. Okay, macam itu sahaja. So maksudnya kat sini, kalau dia nak number of Faraday, you don't have to expand, tak perlu darab dengan yang 96500 tadi. Okay, just use Faraday. Okay, I think the last example, okay, for today. A constant current is passing through ya.
Nak tanya boleh?
Boleh.
Ya, macam mana dapat 0.15 Faraday tu, madam?
Dia darab yang ini bahagi, lepas tu darab dengan 4. Maksudnya 0.03 ni bahagi 1 darab 4. Dapat tak?
Dapat, madam. Thank you, madam.
Jadi kalau yang ini tadi mana? Okay, yang ini kita nak cari yang bawah ni kan. Kita cari yang ni. So 5400 ni bahagi dengan 386. Lepas tu darab dengan 1. Kita balik. Ataupun you boleh letak unknown x. Okay, so you dapatlah 0.15 Faraday. Okay, next last one. A constant current is passing through an electrolytic cell containing molten magnesium chloride for 18 hours. If 4.8 exponent 5 gram of chlorine are obtained, what is the current in ampere? So kita nak cari I, kita ada mass of the gas, kita ada time. Okay, kita ada time. So, sekejap madam nak copy paste. Copy paste. Okay, so in case you macam blur, tak tahu nak start dari mana, this is the diagram that will help you. Okay, so jangan malas. Ini conteng. Okay, dalam exam nanti conteng-conteng tak ada masalah. Okay, tapi make sure you, lepas tu you, bukanlah padam, I mean, yang jawapan tu kena jelas lah. Okay, so kita ada molten magnesium chloride. So magnesium chloride, you ceraikan jadi ion siap-siap. So basically we have Mg2 plus and chlorine minus. So kita tahu chlorine minus pergi anode, magnesium 2 plus pergi dekat cathode. Okay, so means that our chlorine kan halogen, so produk dia nanti adalah chlorine gas. Okay, chlorine gas. So magnesium pula dia akan pergi dekat cathode, okay, dan kita akan dapat magnesium elektrod. Tapi kita bukan nak tengok pada magnesium, kita nak fokus pada chlorine. So at anode, since chlorine is selected, okay, so kita akan tulis equation untuk chlorine. Okay, so if you're not sure macam mana equation untuk chlorine, again, you refer to this table. Cuma, you jangan tiru dia sebulat-bulat sebab ini adalah reduction. So, sedangkan ini adalah equation dekat anode. Anode oxidation. So, kita terbalikkan. Okay, ataupun awak rasa, macam renyah lah madam nak tengok tu, nak tengok ni. Okay, tak ada masalah. Kalau renyah, madam ajar awak cara. Okay, chlorine ni adalah phase dia liquid. Kenapa liquid? Because this is the molten phase. The solution is molten. Okay, kita tahu chlorine ni halogen. So, kalau halogen, dia akan produce halogen gas. Lepas tu, you balance, tambah 2 elektron. Settle. So, it's up to you. Okay, ada 2 cara lah. But before that, kita cari dulu mol untuk chlorine. Okay, by using mass over molar mass. Yang ini kita tak boleh guna betul lah, mass over molar mass. So this is the molar mass of chlorine. So yang ni cuba you kira 4.8 exponent 5 divided by the 4.8 exponent 5 divided by 35.45 times 2. So 6770.1. So quite a big number here. Tapi tak pelik sebab mole dia, sebab mass dia agak besar. Okay, so we have a quite big number of mole. Tak ada masalah. Okay, next, from the equation, kita ada 2 mole of Faraday, 2 mole of electron. So 2 Faraday lah. Okay, 2 Faraday. So 2 Faraday corresponds to 193,000 coulomb. Itu teorinya. Okay, so maksudnya untuk hasilkan 1 mole chlorine gas, you need this much. But you don't want to produce only 1 mole. You nak produce 6,000 plus mole of chlorine. So, ingat, 6.770.1 bahagi 1 darab 193. Cuba kira, 6.770.1 bahagi 1 darab 193,000. Okay, nombor dia agak banyak kat sini. Berjuta-juta, bertrilion-trilion. So you should get 1.3066 exponent 9. Okay, so logik lah sebab mol kita agak besar. But don't worry. So we use this formula, Q equals to IT. Kita nak cari I kan? So charge kita 1.3066 exponent 9 divide with time. Time dia berapa? Ya, 18 hour. Dekat sini lah dia akan cancel nanti. So 18 darab 60 darab 60 saat. So you should get 20,164. Okay, ampere. 20,000. Logik lah. Okay. Sorry ya, Madam tak buka kamera sebab my laptop performance better kalau off kamera. So dia tak lagging sangat. Okay. So, Madam, can I use? Yes, you can. Tapi tak banyak lari pun. Boleh, boleh. 35.5 can. Okay. So before we end this topic, okay, cuba kita tengok sekejap. Sekejap ini. Screen freeze. Okay. Okay. So, cuba tengok beza galvanic and electrolytic cell. Okay. Yang ini medium, you know, should be this one. This one is galvanic. And this one electrolytic. Okay. So cuba tengok beza dia. Kalau galvanic, the process is from chemical energy towards electrical energy. So the reaction is spontaneous. So compared to electrolytic cell, the process needs electrical energy to produce chemical energy. So because of that, the reaction is non-spontaneous. Okay, so kalau kita tengok untuk electrolytic cell ni tidak ada salt bridge lah. Okay, galvanic ada salt bridge. So we expect you guys to know how to write down the cell. Okay, pernah satu tahun, Miriam tak ingat tahun bila, pernah keluar soalan suruh lukis galvanic cell. So ramai orang pergi buat yang ini. Sedangkan galvanic cell yang ada salt bridge. Okay guys, so untuk hari ini, sekejap, untuk hari ini, okay, please do this exercise dan letak dekat Padlet. Sekejap, dia bagi. Ni. Okay, I stop the recording first.